So 2 double angle formulas. The first one is 2 times the cosine squared x minus 1. And then the other one is 1 minus 2 sine squared x. So I would just put those, make sure you get them on your notes, but I would suggest putting them on the top of your worksheet as well, okay? So these are your notes, that's your worksheet. So I would suggest putting them in both places. Okay. I want you to notice a couple of things about the formulas, these identities. If you notice, the left-hand side is always only a double angle. And like I said, to simplify things, we're just giving you the cosine of the double angle. On the right-hand side, both of those angle measures are written as a single angle. So we can look at the formula in terms of a cosine of the single angle or the sine of the single angle. Okay? All right. In terms of the actual math involved, it's not too complicated. But there's a little bit more figuring that we have to do as well, and so we'll talk about that. Okay. So the thing to notice is that we are given the cosine of a single angle. That means we have to plug in on the right-hand side. So you have to think about which form of the equation we have to use. If we're given the cosine, we have to use this form of the equation. And that's really messy. I'm sorry. Let me fix this. It's a minus 1. Okay. Okay. All right. So if we plug in and we are going to figure out what the cosine of 2x is equal to, we're going to plug into this form of the equation. So the cosine of the double angle is going to be equal to 2 times this 4 over 5 squared minus 1. If it's helpful, I would suggest putting that 2 over 1 just to help you remember, okay, the 2 is in the numerator, not the denominator. So this gives us 16 over 25. I'm going to go ahead and write that 1. Instead of writing it as 1, I want to write it as 25 over 25, so I have my common denominator. Okay, so this gives me, we're figuring out 32 over 25 minus 25 over 25. So we get that the cosine of this double angle is 7 over 25. And I just realized I forgot to talk to you about what the directions are going to say. I kind of purposefully did not include directions because sometimes they're going to ask you for just a specific trig function. More often than not, though, usually, God bless you, usually, if you're given a single angle, then what you're going to be looking for or what you're going to have solve for is you're going to have to find the sine of the double angle, the cosine of the double angle, and then the tangent of the double angle. So that's what the directions will usually say is, given the single angle, given this information, now find the sine, cosine, and tangent of 2x, or the double angle, okay? So that's what we're searching for. So we already know this is 7 over 25. We have to figure out our sine and our tangent. And we're just going to draw a triangle. We're going to use Pythagorean theorem. Actually, this is a triple, so it makes it really nice. But there's one other kind of step that we have to add to this process because we have to think about the quadrant. Okay? So I'm going to kind of scoot off to the side here to talk to you about this. If you look at this piece of information, it's telling us that the single angle, so that cosine of x, that single angle measure, is in quadrant 4. So what that means is that our angle measure is somewhere between 270 and 360 degrees. Does that make sense? If we're in quadrant 4, we're somewhere between 270 and 360 if you're thinking about unit circle. You need to look back there. Think about where quadrant 4 is. To figure out where the double angle would be, we just have to double those numbers. So to figure out where the double angle would be, if we double 270, we get 540. And if we double 360, we get 720. So here's what's happening. 540 I'm going to show you guys first, and then I will show you guys. 540 means we are rotating around 360 degrees, and then we're going another 180. So that's where 540 is. The coterminal angle for 540 degrees, if we subtract 360 and find the coterminal angle so that we know where this angle is in our coordinate plane, in our quadrants, we've got to subtract that 360 to find the coterminal angle. So that corresponds to 1 full rotation and 180 degrees more. So that's what this is showing you. 720, right? That was, let me do that in a different color. 720 degrees, think about it. That's 2 full rotations, right? So that means we're starting here 360, and then we're going one more time again, another 360, right? So coterminal angles since when are you lefty?
Never.
Okay, I was going to say, I don't remember that. You're just trying it? Yeah. It never works well for me.
So like the point of the problem is to find what's
the reason why we have to figure out what quadrant we're in is so that we can decide on the positive and negative signs for these other values.
So we're trying to find not just cosine x, but everything else.
Right. Besides cosine of 2x, we've got to figure out the sine of 2x and the tangent of 2x.
But
I need to know which quadrant to draw the triangle in.
Because it says it's positive in quadrant 4, so it does not tell you.
That's where the single angle is, but we don't know where the double angle is. So the double angle is somewhere between 180 and 360. What that means is that it's it's either in quadrant 3 or it's in quadrant 4. So we have to decide which quadrant that is. This value ended up being positive, and cosine we know is positive. If you guys need to draw out your little, all students take calculus to help you remember that. Cosine values are positive in quadrant 4. So this is telling us that this is in quadrant 4. So the single angle is in quadrant 4 and the double angle. That doesn't always happen, but it does quite a bit. It doesn't always happen, but it does happen quite a bit. So I'll just leave it at that. Okay, so we're going to draw our triangle here in quadrant 4. And this is our double angle. I like to draw that 2x in there in that angle to help me remember that, okay, now I am looking at a double angle here. But my triangle is going to look exactly the same. If this is 7 and this is 25, we can use Pythagorean theorem or our triples. It means that this side has to be negative 24. So the sine of the double angle is going to be negative 24 over 25. And our tangent is going to be negative 24 over 7. So, guys, wherever you draw your triangle, you should be able to come up with this math and come up with these answers. This figuring over here is strictly going to help you decide whether something should be positive or negative, because we had to realize, oh, this particular value here is negative, so that's why those values are negative. Sarah, go quickly.
Zarilyn.
Formulas. the double angle where you can plug in, it's the same on both sides. There's no switching there. You just have to decide, and it doesn't really matter. It's personal choice whether you choose to plug into this formula or this formula, okay? It truly is just personal choice. We were given, if you notice on all of these, we were given cosine x, sine x, cosine x. So we were given the single, so we had to find the double. On this one, we're going to be looking for what the sine of x is, the cosine of x, and the tangent of x, right? The good news is we're already told what quadrant it's in. It's in quadrant 2. That's the single angle. So we don't have any math work we have to do for that, okay? So let's look at this example. And then I do want to do number 4 where you see an example where you do have to figure out where the single angle is. You guys are going to try number 3, okay? All right, so we're given the cosine of the double angle. If you go back and look at the 2, 4, I prefer working with this one. I don't know why, just mathematically it looks nicer, I think. So I prefer the 2 cosine squared x minus 1. Okay, so now be careful because we're plugging this number in now on the left-hand side. So negative 3 over 5 is equal to 2 cosine squared x minus 1. So let's add 1, or in this case, let's think of it as 5 over 5. God bless you. Okay. All right, now to solve this, instead of thinking of this as dividing by 2, let's multiply by 1/2. I think it makes the work a little bit easier. And we would normally multiply straight across, but we've got some dividing out we can do. So we get cosine squared x is equal to 1 over 5. So cosine of x is equal to the square root of 1, which is 1, over the square root of 5. So when we rationalize, we get square root of 5 over 5. Now, we do have to decide on signs. In this particular step, we took the square root of both sides in order to solve. So you have to consider the positive or the negative. Our single angle, we're told, is in quadrant 2. Cosine values in quadrant 2 are negative. So this is going to be a negative square root of 5 over 5. Now when we draw our triangle, we want to draw it in quadrant 2. And this is a single angle here. It's also kind of personal preference. If you decide you want to use, you could use this the negative 1 and the square root of 5 in your triangle. You could also use this. I think I'm going to use these numbers. I think it works out a little bit nicer and easier to see. So when we do Pythagorean theorem, we're doing 25 minus 5. So here, this is the square root of 20, which simplifies to 2 root 5. So our sine value is going to be 2 root 5 over 5. And our tangent value, look how nice this ends up. We get 2 root 5 over negative root 5, so we just get negative 2. So the math work is a little bit different, but not really. We didn't have to worry about quadrants. We just had to draw a triangle. So that was nice. But I do want to look at number 4 because that one, you do have to figure out quadrant. So let's look at that one. Questions on that example though first? Okay. All right, let's look at this one. This is number 4. Let's deal with this quadrant business first thing. This is saying the double angle is in quadrant 3. So quadrant 3 is from 180 degrees up to 270. So that's the double angle. So now to figure out where the single angle has to be, because that's what we need, ultimately that's what we're trying to figure out. What's the sine of x, the cosine of x, and the tangent of x? If we just have to divide each of these values by 2. So we get 90 divided by is less than x, which is less than 135 degrees. So 90 to 135, that tells us which quadrant are we in? If we're between 90 and 135. Second quadrant, we're in quadrant 2. Good. All right, so let's plug in. I want to use the other formula also. So negative 2 over 5 is equal to 1 minus 2 sine squared x. I want you to see plugging in with this other formula as well. Okay. All right.
Miss Ireland,
Yeah.
wouldn't you be trying to find sine 2x, cosine 2x, tan 2x?
We're given the double angle though here. If we're given the double, then we're going to find the sine, cosine, and tangent of the single angle. So back here, so now on these, we're given the double, so we're going to have to find the single.
All right, thank you.
Okay? All right. All right, so we're going to subtract 1. That's first. And then I'm going to multiply by this negative 1/2. So I get that the sine squared x is equal to, what does that give me, 7 over 10. So when I take the square root of both sides, I get when I rationalize that, I get the square root of 70 over 10. So that's my sine. I want to draw my triangle. We decided that for our single angle, we're in quadrant 2. I'm going to use these smaller numbers. I'm going to use these numbers rather than these. It's kind of personal preference. So I'm going to use this as the square root of 7 here and the square root of 10 here. I know I'm going to have to rationalize and stuff, but I'm just dealing with smaller numbers if I use those rather than these, right? Okay, so if we square these, we get 10 minus 7. So we find that this is negative square root of 3. So our cosine is going to be negative square root of 3 over the square root of 10. So when we rationalize, we get that. And for our tangent, we get the square root of 7 over negative square root of 3. If we rationalize that, we get negative square root of 21 over 3. You just switched those. This is the word for that. No, just draw an arrow over it, okay?